calculate the impulse of a tree on a 1,485 kilogram sports car if the vehicle is traveling at 93 kilometers per hour in a northerly direction when the driver loses control of the vehicle on an icy road and the car comes to rest against the tree. If the car crumples in 40 milliseconds, find the average force exerted by the tree on the car. All right, so it says calculate the impulse of a tree. So we're actually looking at the change in momentum of the tree. So remember, what do we remember about momentum in a collision? It is conserved. So if we're finding the change of momentum of the tree, that is exactly the same as the change of momentum of the sports car. Okay, they're both conserving. So our sports car is going from some speed down to 0. Okay, it says it's come to rest. So all we need to do is work out what its initial momentum was, and then its final momentum is 0. So the initial momentum will be the change in momentum. Does that make sense? All right. So our change. Well, let's do our momentum first. Well, impulse. Let's do it properly. Impulse is equal to change in momentum, which is equal to mass times a change in velocity. The mass is 1,485 multiplied by our change in velocity. Now, we need to be a little bit careful here because we have 93 kilometers per hour. Ooh. We have to use meters per second. So I get that to be 25.8 meters per second. Okay, so 3.84 times 10 to the 4 Newton seconds. All right. Now you can do this with negatives and you can draw diagrams if you like. Actually, it's always good to draw a diagram. But in this case, if we're looking at the impulse of a tree, a sports car was heading north. It's hit the tree. So which direction is the tree going to move? North. Okay, there's our impulse. There's our change in momentum. 3.84 times 10 to the 4 Newton seconds north. Okay, the last bit. If the car crumples in 40 milliseconds, find the average force exerted by the tree on the car. So that brings us back to our impulse equation. It's equal to force multiplied by our change in time. Okay, that's our definition of impulse. So we're looking for the force. So we can rearrange this and we get force is equal to change in momentum divided by change in time. Our change in momentum is 3.84 times 10 to the 4. Our change in time, it's 40 milliseconds, so it's 40 times 10 to the negative 3. So I get 9.6 times 10 to the 5 newtons. All right, so you'll often get on exams impulse questions and momentum questions. Just remember that impulse and momentum, or impulse and change in momentum, are the exact same thing. Okay, those two formulas will help you out, and the fact that they're equivalent to each other, that'll help you out as well. Okay, so our force times the change in time is equal to the mass multiplied by the change in velocity. Okay, if it helps you, write down everything you know and everything you want to know. That might help you out as well. Any questions? Okay, try the next one.